Hello and welcome to this Edexcel A-Level Geography Enquiry Question Review. And this session is about Coast Enquiry Question 2. How do characteristic coastal landforms contribute to coastal landscapes? So, as always, first thing we do is we check the specification. This tells us the key terms that we're likely to find in the examination that we'll see in the questions, and then the type of terminology we're going to be expected to use in the answers. Now, as always, with the explain questions, it's likely to refer to just one of these sections of detailed content within the key idea. And it's very important that you always look which bits of content link together with the key ideas. With the assess and evaluate questions, you're going to be looking at linking a number of these different detailed content sections, maybe from within the same key idea, but sometimes between key ideas and sometimes between different inquiry questions as well. And this is to show your application of the knowledge, particularly when you're assessing and evaluating different factors, so you can show which is the most important or the most effective. So this session is looking at the coastal landforms and all of the processes that form them. And the key thing to remember in inquiry question 1, we looked at landscapes. We looked at the wider landscape features, and the landscapes will contain many different individual landforms. So we're going to be looking at the processes involved in forming these different landforms, the smaller scale. We're going to be looking at marine erosion, transportation deposition, mass movement and weathering, and then the coastal sediment cell system. As with many physical forms in geography, whether it be coasts, rivers, carbon cycle, they act as a system, and we'll go through that shortly. So to start us off with marine erosion, for those of you doing GCSE or have done GCSE, it's very similar. There are 4 main types of marine erosion, marine meaning the sea, in that we have hydraulic action, abrasion, attrition and solution, and you need to know what those are. Now, the factors which can affect the marine erosion are wave type and wave energy. Are the waves going to be constructive waves or destructive waves? And this will relate to the constructive waves, which have a stronger swash movement up the beach and more likely to be depositional, particularly in bays forming beaches. Destructive are more likely to have a stronger backwash, moving material back off the beach. And these are going to link to different shaped beaches. Now, the wave type and energy is also going to be related to the fetch, the distance which the waves have been able to propagate from, and the direction these waves come from. Now, wind is the main cause of waves. This will cause friction on the surface and create the wavelets which join together in the barrels of energy. In the open ocean, it is not the water that moves, but the energy within it that moves. So the bigger the fetch, the bigger the wind, the bigger and more powerful the waves will be. Okay, so with regards to beach morphology meaning change. Yeah, now these can change for a number of different reasons and over a number of different timescales. So they can, on a short term, change due to the passing of storms, or more with higher wave energy is likely to create more erosion on the beach. Whereas high pressure is likely to generate smaller constructive waves, leading to more depositional features. The tides can also have an impact on a daily basis. In seasonal terms, we're more likely to see more wave energy in autumn and winter, and so leading to more erosion. And in spring and summer, with the calmer conditions, more high pressure systems, we're likely to see more deposition occurring on the beaches, and these will have an impact on the beach shapes. On the long term, we have sea level change, and we look at 2 different elements that we'll look at in inquiry question 3: the eustatic, the change in the volume of water, and isostatic, the changes in height of the land in relation to the sea level. So Marine erosion and the rate of this erosion can depend on a number of different factors. We've already talked about the wave type, the wave energy, and the direction from which it comes from, because the direction can have a direct impact on the transportation, the longshore drift and movement of material, which will help to influence the beach width. Now, beaches are very important because the bigger the beach, the more energy it can absorb before the waves reach the back shore and the cliffs, causing erosion on those. The lithology, the hardness of the different types of rock and the characteristics of the rock can also have a big impact on marine erosion. In those unconsolidated materials are going to be more affected by marine erosion than the igneous and metamorphic. The structure of the rock, as in the layers or dips or faulting of the rock, will also have an influence on the rates of erosion as well. Now, looking at transportation, again, GCSE tells us there are four main types of transportation. From the traction, the rolling of the big rocks, the saltation, the bouncing of the smaller rocks, the suspension of the small particles, and the solution, the dissolved load of certain types of rock. Now, the movement with the swash and backwash along the beach, depending on the angle of the wave attack, will lead to longshore drift, drifting along the shore in the direction of the prevailing wind. But also there is something called littoral drift, and this is the movement of material sort of just off the offshore, outside of the nearshore zone. And this can be created by currents and tides as they move around the sediment cell and the bay systems. We also have deposition, and this occurs in areas of lower energy. Now, it may be that some coasts can have a high energy for some times of the year and low energy for other times of the year, as we discussed in the seasonal times of it. But a main feature of deposition are beaches, and these will often form in bays because the headlands can prevent sort of the material moving out of it too much. So we might get bigger beaches formed in these, and because of refraction of waves around the headland, will often be crescent shaped. We can also have beaches on drift-aligned coasts, such as the Holderness coast, where the prevailing wind or the prevailing wind direction, wave direction, tends to be from the northeast. Now, because these are drift-aligned, there can be much greater rates of longshore drift. So although the beaches are there, the beach material is moved very rapidly along the coastline. And this will have a big impact in coastal management, as we see in Enquiry question 4. Now, where the coastline changes, or there is a headland, or there are estuaries, this movement of material can then be deposited in the more sheltered areas, either in a river mouth, forming spit, which one end is washed away by the flow of the river, so it doesn't connect to other land. Where there is no strong river, bars can often form, enclosing bays between two headlands, leaving water behind it. But we can also have tombolos forming, where the material is moved along and it joins the mainland to an offshore island with a sandy spit. We can also have offshore bars forming as well, where with the littoral currents and depending on the flows of water around major islands, can lead to these shallower areas. Now, also one of the really important landforms is one called a cuspate foreland. Okay, this is found around the southeast in Dunge Nest, whereby you've got two main directions of longshore drift coming down the North Sea from the northeast and from the southwest along the English Channel, leading to two spits, which actually join up. And over time, this land here, this cuspate foreland, joins up, creating this depositional flat landforms with lots of berms of sand and shingle within it. Then again, we have the processes of weathering and mass movement. Now, the weathering is the breaking down of material in its situation. It's not like erosion where it gets moved away from it. and there's biological, whereby it's the nature of the plants and the animals burrowing in and weakening the rock. It could be chemical, with the acid rain or the seawater dissolving the rocks. And then we have mechanical, which could be freeze thaw in certain climates or exfoliation, particularly in those layered rocks where the rock heats up and the outer layers will crack because it's not very flexible. We then also have mass movement, which is the material moved down by gravity. So often this material is weathered, but it could be impacted by high levels of rainfall in permeable rock, or where there are different layers of rock. So the structure, the geological structure, the layering can also have an impact on it, as can its lithology and whether it may fall as blockfall, landslides or rotational slumping. Then we come on to sediment cells, and this is where the coast acts as a system. Systems are things which have inputs, there are movements, flows or transfers between them, there can be sinks or stores, and then there can be outputs as well. So we can see here we've got the main inputs. These can be, this is the sediment within the coastal system. Now this could come from eroded materials, the material brought down by rivers, the seabed or offshore sandbanks. These are transferred by transportation, longshore drift, littoral drift, currents and tides. And these then can be put into sinks where the material is stored, such as beaches, spits or bars, or the depositional features. So it's the stuff that we've already covered. There are limited outputs. Sometimes this sediment, particularly in storm environments, can move between the different sediment cells. Now, around the UK, there are 11 major sediment cells, and the coastline is broken up. Now, these sediment cells are often formed, or the boundaries of them are often where there are major headlands or major changes in the direction of the coastline. And these sediment cells can also be split into subcells, where there is only a small amount of movement between the different subcells, but very little of an output between the main sediment cell itself. And this is very important in understanding the management of coastlines in its holistic form today. Now, coastlines, by their nature, try to seek dynamic equilibrium. This is where sources and inputs equal outputs. Now, there are a number of different feedback mechanisms, and feedback mechanisms are very important in geography, from coast to waters and to the carbon cycle. A positive feedback is one which will accelerate change. For example, if you put coastal protection in one place, it may reduce the sediment flowing, the source, lower down the coastline. This reduces the beach size or the sink, which will lead to more wave energy reaching the coast and the cliffs, which will lead to more erosion, which may need more coastal protection, and so this accelerates change. But there are negative feedbacks as well, and this is to help restore the equilibrium. For example, it may be that with a large storm, there's big erosion of the cliffs and beach, and this sediment may get placed offshore. Now, as there is sediment offshore, this can absorb some of the wave energy, meaning there's less wave energy at the beach, which can lead to more deposition on the beach, forming a bigger beach, which is likely to reduce the rates of erosion. So there we have a very quick summary of Enquiry question 2 of the different landforms and processes that are found within the coastal system. Now, it's important, although when we look at coast, we look at them in different Enquiry questions. Actually, everything we do is all linked together, and the different sections, as you will see from this presentation, are all interlinked, not only to the different coastal systems, but also into weather and management and the risk equations that we see with tectonics as well. So I hope you found this useful. Thank you very much for watching. Take care. Bye.